So far we've been looking at the explain command running in the query planner mode right here. The query planner mode is very useful. It's also the default mode for explain. But there are two other modes I want to go over. One is the execution stats mode, and the other is the all plans execution mode. And they're sort of increasing levels of verbosity because the execution stats mode includes the query planner mode, and the all plans execution mode includes the query planner mode and the execution stats mode. Query planner tells you mostly what the database would use in terms of the indexes, but it doesn't tell you what the results of using that index are. For that, we're going to have to use the execution stats mode. Let's take a look once again at the shell. We're going to use the same data that we used in the last lesson. And just to review that data, it's a bunch of data. There's a million different documents with values for A, B, and C. And we can also look at the indexes on the collection. The collection is called example. And you can see there's an index on underscore ID, of course, and one on B, and one on A, comma B. Now let's run a query using the new execution stats mode that we just learned about. So once again, we're going to get an explainable object. But this time, we're going to give a different option. This time, we're going to create that object with execution stats as an option. And we're going to put the result in this exp variable. Now we're going to call exp.find, and we're going to look at one document in the collection, and we're going to, of course, run the explain command in execution stats mode on this query versus actually do the query. And now let's look through this data and see what there is to see. So once again, we've got the query planner mode, and the query planner mode tells us that it is going to use the A underscore B underscore 1 index, and that it will pass that along, and that the parse query was this. All good. It tells us that there was a rejected plan, and the rejected plan was to use the B index on this. That's helpful. But it doesn't tell us what would have happened if it used each of these. So the execution stats over here will tell us the execution stats for the winning plan. And there are certain key items that I want you to pay attention to. There's a lot of data here, and we're not going to look at all of it. But one thing I want you to notice is the number of documents returned right here. That's the number of documents that the query actually returned, or would return if it were run to completion and the data was brought back to the client, which is 100 documents. We can see the execution time millis, which is the time for the query, which is unmeasurable in this case by this granularity of clock, 0 milliseconds, a very fast query. And we can see that there was 100 keys examined and 100 docs examined. So that tells us something. It tells us that the index worked pretty well. We looked at all of 100 keys and we got to the 100 documents. And then you can see here, as we go down, we can see for each stage, we can see the number of documents returned from each stage. And this is an inner stage here where it actually did the index scan. And in the index scan, it returned 100 documents. You can see the key pattern that was used for the index, which was, of course, AB, and the selectivity, and again, what it used to select on, which was A, min value 17, max value 17, B, min 55, max 55. And you can see it also provides an estimate of time for this stage of the query, which is 0. And you really read this from the bottom to the top if you're trying to understand the different stages of a query. Okay, and because this part is an actual index scan, it doesn't actually have any docs examined part of it. But if you look in totality, you can see that we examined 100 keys, we got 100 documents, and that sounds awesome, and it was pretty darn fast. Now let's see what would happen if we didn't actually have this particular index to use. We were selecting on A and B, and we had an A comma B index, so that was a pretty ideal index. Let's drop this index on A, B, ascending. So we'll drop the index, and there was 3 indexes, now there's 1. Excellent. All right, so at this point, let's run the query again. We can go back in our history by just going up arrow in the shell. And we already have an explainable object. We can use it again. We're going to call find A17, B55. Same exact query. And now let's see what happens. All right, so the results are slightly different this time. First of all, the winning plan, once this awesome index is missing, the winning plan is to use the B index. It's not as good an index, but it runs the B index right here. And it says that it's going to use it with the bounds 55, 55. Makes sense. And then it's going to pass that up to the fetch stage of the query, which is after the index is run, it fetches the final documents. It's going to look for the documents that have A17. All right, that's good enough. Sounds good. And now we're going to go down to the execution stats and see what happened. And now things are a lot different. So the first thing to notice is that there's actually an execution time here of 5 milliseconds, which is much, much longer than 0, infinitely longer than 0, although of course the first one wasn't actually 0, it was probably just not quite 1. This query is a lot slower, and that's not surprising, because if you look down, you can see that we examined 10,000 keys and 10,000 documents. And that's because the first stage of this index scan on B returned 10,000 documents, then had to be examined during the fetch stage. Let's see if this tells us that information as we go through it. So let's see. How do we understand this? All right. The innermost document was the first stage run, the input stage, and that ran a query using the index B. And you can see that it returned 10,000 documents as part of that. Or I should say, it returned pointers to 10,000 documents because, of course, the index scan didn't really return the documents. And then up here, those 10,000 documents had to be whittled down. They were all examined with a filter of A equals 17, and they were whittled down to a final number of documents of 100. And whenever you see the number of documents examined much larger than the number of documents returned, you know that you did a lot of extra work, that you took a lot of extra data out of the database, and at some point it had to be inspected and then rejected before it was returned to your actual client program. All right, so that's what happens when you give the option for execution stats. Now, we said there's a third option, and that third option is all plans execution. So let's run it that way. First, let's recreate our index. So db.example.createIndex, A ascending, B ascending, about 1 million documents, a few seconds. There we go. Our index is back in the collection. Now let's get a new explainable object. My new explainable object will have the option all plans execution. Now, what does all plans execution do? Well, all plans execution does what the query optimizer does periodically. What the query optimizer does periodically is it runs all the possible indexes that could be used, and it runs them in parallel, and then makes a decision about which one is fastest. And it periodically does this, and then it remembers which one is fastest for a certain shape of query, and then always uses that index. But when you run the explain command in all plans execution, you are running the query optimizer that periodically runs to determine what index would be used for any particular shape of query. So it gives you even more information about the different possibilities. Because remember, in the last one, what we saw were the execution stats for the winning plan. But we didn't see any execution stats for other plans. So let's see what happens now. We're going to do the same exact query we did before. And now what do we get? We get a lot more information, certainly. We have the execution stats that we had before, and they look pretty much the same. We did an index scan, and we decided to use the winning index of A, B. But what about the all plans execution area, which is right here? What does that tell us? Well, let's see. The first one is actually the most interesting, because the first one is considering using the B index. A little hard to read on screen. By the way, this all plans execution is an array of different plans. The first one was actually rejected. It returned 0 documents. And the reason it was rejected is that the database ran the query using the B index right here, B_1. And when it did that, they examined 101 keys. Now we know from previously when we removed the A, B index, that to complete this query with just the B index, you'd look at 10,000 different documents. But in this case, you looked at 101. Well, why is that? Well, the reason is that 101 was as many as the database needed to see to know that it was a loser. Because, and you'll see here, it says that it returned 0 documents. So it says, didn't return any documents from this plan. Because this plan was eliminated. It said, this is not the best plan. I know that because I got to 101 documents examined, and I have a plan here, which is the second plan in the all plans execution, which is going to return 100 documents and only look at 100 documents. I look at 100 documents, I look at 100 keys. And that's using the A, B. So now you can really see the logic that the database applied to make the decision, which is as soon as it saw that using the B index just on B, was going to look at more documents than using the A, B index, it immediately abandoned that path and didn't follow it through to completion. So although this all plans execution mode will give you some execution information about alternative paths to satisfying this query. It won't tell you everything that would have happened because it treats it just like the query optimizer. When it knows that it's bad, it stops. And if you remember, when we removed the actual A, B index and ran this query, it told us it looked at a lot more documents than that when it used just the B index. Now, one thing to keep in mind with a database is it's good to have an index for every query. That is, that every query should hit an index, but it's also important that every index that is on your collection, that there be at least one query hitting it. Which is to say that when you have an index on a collection and it's never chosen, it's never selected, it's just a waste. And you're wasting time inserting into that index and keeping that index up to date when in fact you don't need to be. So you want to have a good balance between the indexes on your collection and the queries so that all the indexes get used and all the queries have at least one index that can satisfy them and work efficiently. All right, it's time for a quiz. Let's look at this option for verbosity. Given the following output from explain, what is the best description of what happened during the query? Now this looks a lot like what we did in the class. We are creating an explainable object and looking at this query. So examine these results carefully and then figure out what happened. And then pick the right answer.